In this video, I'm going to try to show you how to take a graph and use the information you can see on the graph to find the equation of a function. Now, in this case, I'm going to show you what the parameters are that I've got a sine graph, where I have an A value, a B value, a C value, and a D value. And A, B, C, and D are currently 2, 5, pi, and 2. Now I'm showing you those parameters in this case. In the next example, I won't be showing you the parameters. I can close this little, I can close the parameters box. Anyway, it doesn't matter for now. I will also warn you, this is a new piece of software for me, and I'm not crazy about the way it works. It's hard to write clearly, so I know that I'm going to be struggling with that. So just bear with me as I work with this software. What I will do is go ahead and create the format for the equation that we know we're going to be looking for. I'm going to do that somewhat slowly. I know I've worked with this a couple of times now, and I know that it's kind of fussy, especially when you're writing on the screen. I'm using the pre-factored form of the equation because I know from experience that it's easier to find the value of C if B has already been factored out. All right, so let's take a look at some of the features of this graph. One of them is that it's clearly either a sine or a cosine, and it might not be. It might be secant, or it might be a cotangent. But this one's clearly a sine or a cosine. If we didn't know, the fact that it's a sine has been given by the equation here, but we might not know that. So hopefully, as I go through this, I'll show you how to figure out whether it's a sine or a cosine, or how to express it as either a sine or a cosine, because remember, a cosine is just a shifted sign. So one of the first things that I noticed is that instead of being centered at 0, like this, right? Sine graphs normally look kind of like that. Instead of being centered at 0, it's centered way up at y equals 2. That's my midline. So this graph has been shifted from 0 up, and it's not working, 0 up to y equals 2. That means that D is 2. Now I'm going to grab a color that I hope will still be easy to see, but be different from this black here. I know that D is 2 just by looking at the graph, right? That's a pretty easy one. I'm going to erase some of my, actually no, I'll leave it there, because the next thing I'm interested in is the amplitude. That's another fairly easy one to grab. The amplitude is the distance above and or below the midline, right? And in this case, both of those are 2. Now I can see these in my equations here, in my parameters, but remember, you're not always going to have that. In fact, that's the point of this video, this exercise, is to show you how to find the equation of a graph if you don't know it, if you just have the graph. Right, I've got my purple pen here. I also know that the amplitude is 2. All right, now the other two things I need to know are how far to the left or right the graph has been shifted and how many cycles there are in one period. Now, I've messed up and not put this in terms of 2 pi, but I can estimate 2 pi. So I'm going to erase the annotations that I've got on the graph so far, just to kind of keep things tidy. And then let me trace a single cycle of sine. It kind of looks like sine is starting here. And there's one cycle. And then here's another cycle. And I've got to get to 2 pi. And 2 pi, since 1 pi is 3.14, 2 pi is about 6.24. So there's another cycle of pi, another cycle of sine. But I can only really get to about there. Let's see, 6.2, that would be 7 there. That would be 6.5. So yeah, that's about right. 6.28 is about here. And so I've got, I don't have a full full final cycle of sine. But what I do have, let me highlight that one in a different color. This is my partial cycle of sine here. But I've also got a partial cycle of sine back here. So between 0 and 2 pi, I actually have 5 full cycles of sine. Now, it's a little titchy here. It's a little hard to see because, like I said, I haven't got my axis measured in radians, and so it's a little awkward. But I'm going to say that first of all, I can tell that it's 5, right? Because if I look at the panel of parameters, then I know that it's 5. And that's this number here. But the other thing is that I will only give you these in integers if I expect you to do this by hand. Okay. All right, so my b value is 5, and now I have to figure out how far over the graph has been shifted. Well, if we look at what we know the c value to be, we know it to be pi. That's my c value there. And pi is at about 3.14. So that would put me, let's see, I think I'll erase my current annotations. Now I'm cheating this time because I want to make a point. I'm going backwards. 3.14 is about here. And this is not working. There we go. This c value that's given in this case would seem to indicate, trying to find a color that will work, that I have to start here and go for each sine graph rather than starting here. It's not working. Come on. Pencil's not working very well. Starting there, or starting there, or starting here, or starting here. The thing is, you can actually start anywhere. That's the beauty of sine and cosine, or actually any of the trig functions. They can be started anywhere. In this particular case, we've been told that we're starting, my highlighter's not working now. That's my eraser, that's why. We've been told that we're starting over here at pi, but in fact, I could choose to start anywhere. I could choose to start just here. There's my first full cycle of sine. So the question is, what is that value? And that's the trick. Hopefully, I'll be a little bit more careful when I give you here's another one here. When I give you these to work on, and I'll have these labeled so that you can tell what these values are. But any of these is a perfectly legitimate alternative starting point. Now this one works just fine as well, and we know that this one is pi. So we could change c to pi, or we could change it to any of these other values. The thing is, it's kind of hard to tell what any of these other values are. So I'm going to go ahead and stick with pi, but just know that it could actually be whatever any of these other pink values are on the x-axis. In other words, I could say, I could make my c value whatever this is. It looks like about pi over 2. That might be pi over 2. Could it be pi over 2? If I start here versus here versus here versus here, there's 4 different places to start. The fourth one of which is about pi, but the first one of which is not at 0. So that's unlikely to be pi over 2. And there you have it. I have, let's find a different color highlighter. I have found my A, B, C, and D values, A, B, C, and D, just by looking at the graph. So now let's take a look at another one of these, except that in this case, I won't be showing you these values here. So we won't know in advance what those values are. Before we do that, it's just occurred to me, let me make one more point. It would be possible and quite acceptable to do this problem as a cosine. So let's see what happens if we do that. I would argue that the first thing we want to do here, and in fact the first thing you might want to do in any case, is identify one cycle of, in this case, cosine. So the first full positive cycle of cosine that I see is here. And that's one cycle. Let me grab a different color of pen. Here's the second cycle. The third cycle. I got to get to 2 pi, remember? The fourth cycle. And I can get all the way, I can get my fourth cycle here. 1, 2, 3, 4 cycles. And then I'm going to switch to a different color again. Maybe, well, how about dark blue? I have just this tiny little bit more to get to out to 2 pi. Remember, I'm doing this because the period of cosine is 2 pi, just like the period of sine is 2 pi. Actually, it's a little bit more than that, isn't it? A little bit more than that. Let's see. That's 7. 6.25 is about there. So 6.28 isn't much farther. So it's maybe more like this. In fact, it looks like it goes to, about there. Okay. Terrible job of drawing that, but that's, I'm just highlighting what the cycles are. Now, that's an incomplete cycle of cosine, but I didn't start at 0 either. I'm trying to get out here to 2 pi, but I didn't start at 0. So I have this other partial cycle of cosine as well. And if you add them together, if you can pick this one up, this piece, and stick it over here, sure, it starts before 0, but it adds to that incomplete cycle of cosine, making the whole thing. I'll just go ahead and draw it in. I'll do it in a dotted line. Makes this whole thing another complete cycle, right? Starting about here and ending about here. So I can still get my 5 full cycles. It just happens to be this time cosine. All right. Also notice that the midline is still up 2 units. So my vertical shift is still 2. My amplitude is still 2 as well. Sine and cosine are just shifts of one another. The only thing that's going to be different is my C value. I've just realized I made a mistake in the previous example where I was talking about sine, and I can do the same thing here, and that is that this should not be a plus. It should be a minus, because I looked at it as though it had been shifted to the right, and so I need to make that a minus. If I had chosen to start my sine graph back here, then I could have left it as a plus, but I didn't. So the same thing's going to apply here. If I find my first full cycle of cosine, I could say that my graph has been shifted over by about this much. That appears to be roughly pi over 2. Let's see if we can find a different cycle of cosine that's easier to read. This cycle here looks like it's at, well, I don't know where I would guess that one was. How about a third one? My point is that you can start at any of these, start at the beginning of any cycle of cosine, figure out where that is on the x-axis, and that's your horizontal shift. I'm trying to draw an arrow and it's not working. So I'm just trying to find one that's easy to work with. That one there. It almost looks like, well, I really can't tell. This one here sort of starts about there, and that's just shy of 2 pi. So I'm going to say, this is pi here. You know what the software needs is a pointer tool. I don't have a pointer tool on this the way I do on my regular software. That's kind of annoying. If that's pi, that looks like I'm going about there. That's one of the reasons that a sine wave was easier to use here. Half of pi, let's see, half of pi is about 1.6, so that would be about here. That could be, actually, that could be another place to start. Oh my goodness, this tool is just terrible. You have to draw really slowly. 1 point. Does that even do a point?